Hello students, today we will be dealing with class 11 bridge course Fundamental of Derivative online tutorial 7. We will be discussing about the concept of instantaneous rate of change, slope of a tangent and their relationship with derivative. Let us have a look at this figure. In the above figure, a tangent drawn at point P on the curve of a function y equals to fx makes an angle theta with the positive direction of x axis. We know that the slope of the tangent of point P is tan theta. We all know that. Now, let us analyze another figure. Please draw this figure on your copybook, so that when I will be moving forward with interpretation of this graph, you can match with this. Okay, I am holding for a minute. In the above figure, we have 3 points, namely P, Q and R having coordinates x1, y1, x2, y2 as we can see, and x3, y3 on the curve, which is a none other than straight line, right? Let the straight line makes an angle theta. This straight line makes an angle theta with the positive direction of x axis. So, we have slope which equals to tan theta equals to y2 minus y1 by x2 minus x1, okay, equals to delta y by delta x. Here we have y2 minus y1 by x2 minus x1 equals to y3 minus y2 by x3 minus x2. So, here the slope is uniform throughout the graph. Now, if we can imagine a situation where x3 and x1 move closer to x2, let us have a look at this. x1 and x3 are moving closer to the middle point x2, then their corresponding ordinates y1, y2 and y3 will be almost merging together. That is, in that condition, function of x1 will be almost equal to function of x2 will be almost equal to function of x3. Okay. So, now we can imagine a situation that I have said where x3 and x1 move closer to x2, that is delta x tends to 0, and in that situation y1 and y3 will also eventually almost be merging with y2. That is, in that condition, which is known as limiting condition y1 and y3, these two ordinates will be almost equal to ordinate corresponding to x2, that is y2. In such condition, we can express the slope as follows, and that is tan theta equals to limit delta x tends to 0 delta y by delta x. Such above expression can also be written as tan theta equals to limit delta x tends to 0 delta y by delta x equals to dy by dx. Okay. So, we may conclude that in limiting condition, slope equals to the rate change, which is nothing but derivative. Now, let us assume the above scenario for a position time xt graph. Can you say what will happen in this case? Let us have a look at this. This situation has been shown in this above position time xt graph. Let us assume the position of a particle at x1, position of the particle at x1 at the time equals to t1, which is at point P, and the position of particle x2 at time t2 at point Q. So, at point P position x1 and time t1, at point Q position is x2 and time is t2. Clear? So, here we have slope of xt graph, and that is tan theta equals to x2 minus x1 by t2 minus t1. Okay, and that is delta x by delta t. Here theta is the angle made by xt graph with positive direction of x axis, as we can see from the graph. So tan theta equals to delta x by delta t equals to change in position by change in time, and that is average velocity. In limiting condition, which we already know what it is, we have tan theta equals to limit delta t tends to 0 delta x by delta t equals to dx dt equals to rate of change of position with respect to time, and this condition is known as instantaneous rate of change condition, and it is the momentary change of position with respect to time, which is the slope of xt graph. So we have instantaneous rate of change of position with respect to time is the slope tan theta of the xt graph. Here tan theta equals to dx dt, which is rate of change of position with respect to time, and it is known as instantaneous velocity. Since here in this case the slope of xt graph, that is tan theta, is constant or uniform throughout the motion, so the motion in this condition is a motion with the uniform velocity. But the actual essence of instantaneous velocity can be achieved only in the case of motion with non-uniform velocity. Okay, so let us have a look at this condition. Look at this graph. It corresponds to non-uniform motion, and we need to look forward for the reason of its non-uniformity. The above position time graph, that is xt graph, describes the scenario of a motion with non-uniform velocity. Our question is, why it is a motion with non-uniformity? As of now, we know that the slope of xt graph describes velocity, right? We know that. But what is happening over here is that the xt graph is a curve which is not a straight line, right? Here it is the curve. Follow me. It is the curve, and these three are tangents. These three are tangents which are making angles theta 1, theta 2 and theta 3 respectively with the positive direction of x axis, and these tangents are at point A, B and C respectively on the given curve, xt curve. Okay, xt curve or st curve. Okay, position time curve. So we need to draw tangents at a point at which we require to compute the velocity. From the figure we see that we have already drawn the tangents at different points. Here we have taken three arbitrary points on xt graph, namely A, B and C. In order to find out the velocity at these points, we have drawn tangents at these points, as we have seen. Let the angles made by the tangents at point A, B and C be theta 1, theta 2 and theta 3 with the positive direction of x axis respectively. In order to compute the slope of at these points, we have calculated tan theta 1, tan theta 2 and tan theta 3. Since we have theta 1 less than theta 2 less than theta 3, theta 1 less than theta 2 less than theta 3, so we have also tan theta 1 less than tan theta 2 less than tan theta 3. Okay, since we know the slope of the tangent at any point on xt graph is velocity, here we have v1 less than v2 less than v3. Okay, v1, v2 and v3 are the velocities, instantaneous velocities at the points corresponding to A, B and C respectively. So we have different velocities corresponding to different points in the motion. Here v1, v2 and v3 are the instantaneous velocity, as we have already said. Momentary, this is momentary velocity, that is velocity at a particular point in a motion, and these velocities are corresponding to the points A, B and C respectively. Therefore, we can conclude that the given xt graph corresponds to a motion with a non-uniform velocity, And from the above graph, we can also infer that as the velocity is increasing with respect to time, the motion must be an accelerated motion. Okay, students, keep learning. We will be coming back with the next tutorial. Till then, bye.